So if you look at block.h file, you can see that block internally is represented by a two-dimensional vector. And inside the vector is containing the HSLA pixels. Right. And you have like 5 functions you have to implement. So with a given image, if that's your like PNG image, given an XY position and a width and a height, width, height, you want to put all the pixel inside of this block, like this part of image, to a two-dimensional vector called data. So it's a vector inside containing vector of pixels. Okay, so remember your PNG image is actually represented by, it's made up of different pixels together. So you can see it as like different pixels placing together to make up like a PNG. So let's see what function you have to write for this. Your height and width function is actually depending on your constructor. There's two ways you can do it. The first way, let's try to represent this yellow block here. All right. If that's the yellow block I draw in the picture up there. And yeah, I tried. Okay. So that's all the pixel you want to store into the data structure. There's 2 ways you can do this. The first way, you can create a vector for every column. So you can create a vector for every column and push everything in. And then put all these vectors in a big vector called data. If you're planning to do it this way, then your width is going to be data.size. But there's another way you could do it. You could make a vector for every row and put every row vector into a data vector. Then your height will be data.size. Does this make sense to everyone? Yeah. Okay, so how do you create a vector? This is a question which I was being asked a lot in the office hour. Vector, when you first declare a vector v, you don't create an empty space for it, like arrays. If you declare an array, you will create empty space, so you can just directly put stuff into it by using index. But for vector, if you just declare it, you don't have any space for it. So you have to use a function called pushback. And you put the data you want to push back in there, or like pixels. Every time you call pushback to a vector, you create a space for it and then put it into the next empty index. So if you call pushback and the first time, it will put something, a pixel, into index 0. And then if you call pushback another time, it will put pixel into index 1 and so on forth. So you can create a vector using pushback function. Pushback kind of means if you push an item back to the right-hand side. Let's go back to the function. So that's basically the idea for height and width. But how to write a constructor? You have to write a double for loop. For the outer for loop, you're creating a vector for every row or every column, depending on your choice. And then the inner for loop, push every pixel in that specific row or column to the vector you created. and afterwards you push the vector you just created into the data vector. The render is kind of the same thing, but opposite way around. If you wait, okay. So constructor is you're putting pixels into the image to your data vector, but render function, you're just putting data vector pixel back to the original image with a given xy point. So if your data have a size of like width and height at 2, then you put everything inside in the data to override the original pixel in the PNG image you're given. Here, okay. So if you look at this render function over here, you're writing 2 for loops starting from xy position. And you're going through width and height depending on your data size to override all the pixels in the given PNG image IN. Okay. And grayscale is kind of the same thing, but there's no, you don't have to change everything in the image. You're just changing the pixels data in your data vector. So for grayscale, you're just going through every pixels in your data vector to set its saturation to 0. Any questions for block? Yeah, sort of, that's it. And you guys want me to go over the destructor for grid, right? Or, yeah. Anyone know why we need a destructor? Or what are we going to call a destructor? If you allocate space on heap memory or any stack memory, you are going to use a destructor to deallocate it. So for grid, basically we have stack and heap, right? Stack, heap, here. And if you call grid, G equals to new grid, you're allocating something on the heap. You're allocating a space on the heap. And if you call delete G, it's gonna call your destructor for you in the heap memory. And also destructor is sometimes used also for static variables. If you declare something static, I can think of something. Do you have any static? Yeah. Some method, like if you are inside some function, void function, sometimes you're going to call the constructor without a new keyword. Is that in C or C++? Yeah. How about differently? Yeah, or just don't worry about it. Yeah.
Deleting.
Mm-hmm.
Like that's the reason why I made you write a destructor. That little weird tilde thing.
Yeah.
And that's also one reason why you can just, I don't know if you guys did this, but you can just call clear in your destructor. And that achieves.
But the reason you're calling clear in the destructor is because you're also going to use clear in your copy constructor. So you're going to write the same code twice if you don't write like clear separately. So that's why we factor clear out of the like destructor. Do you want?
Do you want to do clear and copy first?
Okay. see if it's yes. So I'm going to talk about the rotates. So I think I'm going to start with the given rotates. So there's a given image for a visualization of what's the grid look like. I don't think it shows properly here. So I'll just maybe draw it here. So in grid you have rotates. So rotate R and rotate C. So they are basically the same idea. It just you switch the column and rows in your code and it will work. If you write rotate R and you switch column and rows and you get the rotate C. So I just cover one of those. So for rotate, what we have is we have a head of columns, right? There are pointers pointing to some blocks or nodes. You have a head of rows. So this is what's our grid look like, and there's also like pointers pointing between the nodes here as well. So I'll just draw maybe a simple one to illustrate how the rotates works. I mean, you all know how this works, so just a simple one will be enough. And there's one here, one here, one here. So this is a 3x3 grid, and let's make it smaller. Okay, so let's give maybe the nodes numbers. So this is 1, 2, 3, 4, 5, 6, 8. Okay. So if I would rotate the second row, it will be something. Copy and paste. Okay. If I rotate the second row, it will just change. Maybe I'll say it's 5, 6, 4. Right? So it's rotate maybe the second row like by the count is 2, right? In this case. So what we want to do in the rotate R is we want to make the changes to the pointers so that when we render the image, it will actually change what this look like here to what's look like on the right. Okay. So what we can see here, the first is head of rows. So originally the head of rows will point to the 4, but in the new image, the head of row will point to 5. Right? The second thing we notice is the pointers between the nodes. So if we have like 5, when we call up, it's going to point to 1 in the new image, but when we call 5 up, it's going to point to 2, right? So that's also the thing we need to change. But notice we don't have to change anything in that row. So because it's doubly linked list, so the 4 have a right of 5, right? Here the 4 also have a right of 5. So you don't have to change these pointers. This pointer that does not need to be changed. So we can just move the pointer of the head to maybe the new node to the 5, and we don't need to change anything, so that the row will be fine. But we have to change the vertical pointers here to be something. We need to change the vertical pointer from left to right. Okay. The third thing we need to do is the head of columns. So if we are changing the second row, then we don't have to change head of columns because it's nothing to do with that vector. But if we are going to rotate the first row, we're going to do a rotate here. We want to change the head of columns, right? Because originally the head of columns would be 1, 2, 3. After rotate, maybe it's going to be like 3 and 1, 2, right? So we need to change the head of columns in the order of 3, 1, 2. So yeah, that's also a case that we need to consider. Okay. Any questions right now? No? Okay. So let's go over to the code. So the rotate R, first thing is to initialize the value. So what I did here is I'll just mode the count, because if your count equals the number of columns, then you're doing like nothing. You're just rotate the whole thing, and you move the head pointer back to the original position if you rotate number of column times, right? It's just a cycle. So I'll just mode it so it will be smaller than the number of columns. That's the actual work we need to do. And the rows, the same thing. We mode it by the number of rows. And if the count is same as 0, then we just return. So the next step is what we did over here is we're going to change the head of rows. So first thing I'll do is get the first row element that is currently the head, is head of row, and the r's element of it is a row we are going to rotate. And I'm going to move the pointer to its left for count number of times, which is a new head. Okay, so if we're going to do this here, is our head is here, and we move to the left 2 times. That is head, and the second time is head 2. This is head 3. So this is the original head. I move to left once, I move to left twice. So we're pointing head to 5 right now. So the new head will be here. Okay? That's the first step we did over here. Here? Any questions about this step? Okay. The second step is reassigning the pointers. Okay. So we see that we need to reassign those vertical pointers. So what we have right now is the 1 is still pointing to 4. So I'm just going to erase maybe these ones. So currently 1 is pointing to 4, and 2 is pointing to 5, and 3 is pointing to 6. So this is currently what our pointers look like for the first row and the second row. Okay, and we need to reassign the pointers so that 1 is pointing to 5, and 2 is pointing to 6, and 3 is pointing to 4. So what I did is I will grab the head of the first row and the head of the second row. I'm pointing those two together, like to each other. And I'll move to the right, pick these two elements, and pointing them to each other. Okay? And do it for each element in that chain. And those pointers will be aligned. It's not this here. Okay. So I would say the pre-head of row is the current row you are rotating, and it's the previous row of that. It's the one row that is one above the current row. And the next head of row is the one row that is below the current row. Okay, so you can see the current row is just the head of row R, right? And the previous is R minus 1. But if R equals to 0, then it's going to be the last row. Okay? And the same thing here. If R is the last row, then it's going to be the first one. Otherwise, it's going to be R plus 1. Okay? Okay, now I'm going to do a loop that's looped through everything on that row and pointing them to each other. So let's just do maybe the first element. So the first head down is the current head, right? And the current head up is the previous head. That is the one head above current row. And the next head up is the current head, and the current down is the next head. So let's draw a new graph. Let's say we have two linked lists, right? What I did is reassign the pointers. So because we know this is 1, 2, 3, and like the index, right? So this index 1, index 2, index 3. We want to do is for the first index, the first element is pointing to the first element of the second linked list. And the first element of second linked list is pointing to the first element of the first linked list. I do the same thing to the two linked lists down here. So that's what we did over here. The second thing what we do is we move each pointer to the right. So currently 3 pointers are pointing to here. The second step is we move the 3 pointers to the new position. And when we do the while loop, I will reassign the pointers of the second element, right? And then we're going to move the pointer to the right again. Let me reassign the pointers here. Okay, until the head of row goes back to the start of the row. That is 1 full cycle. Okay. Any question about this step? Okay. So the third thing we need to do is to fix the head of column. So the only thing that will break the head of column is when we are rotating the first row. So if the R is 0, then we're going to fix the head of column. That is, we're going to reassign every pointer to the head of column. So I do a while loop over the pointers of the first row here. So I have a pointer that is maybe like call it temp. That's pointing to the first element of the first row, right? And we rotate the first row. So the head of column will now be like something random. That is not what we want to the head of columns. So I would say I'll have a counter I, equal to 0, that is counting what's our position right now in the row. So first, when we assign our temp is pointing to the first element of the row, our I is 0. So we are assigning the first element of the head of column to be temp. Okay, so that's 0's element. And then when we're going through the next iteration, that is I equal to 1, we are going to move the temp here, right? And we are assigning the temp to the second element of the head of columns, okay? So now the second element is pointing to the second element of the row, so that's what we want. And we're going to iterate that again, and I equal to 2, and the third element is going to pointing to the third element of the row. So what we did here is we first assigned the current pointer, that is our temp, to the first element of the row. And then we're going to assign the head of column, the S element of head of column, to the current pointer. And we move the pointer to the right. At the same time, we will increment the I. Okay, so we will do that until we go back to the head of the row. That is how I did it. So, any questions here? Okay. Step 1. This one? Okay. Sorry?
So this is to find the node that will be at the start of the row.
Yes. More questions? Yeah.
The last step where you're fixing the head of column,
Mm-hmm.
what exactly do you need to do? Because does it change?
It will change when you rotate the first row. So let's say you have head of columns here. Let's say this one is 1 and 2. So current head of column is 1, 2, and 3, right? If you rotate the first row, and let's say it's become 3 and 1 and 2, okay? But if you don't change the head of column, it will still be 1 and 2 and 3, which is something like this, which is not exactly what we want. So we need to reassign the pointers so that 1 is pointing to here, that it becomes 3. This is 1, this is 2. So that's what I did for the third step. Okay? More questions? Okay.
Sorry, can you go back to the second step?
Okay.
Is it possible to do this like the way you did it? You were like iterating through like pretty much you were setting like the up and down of
Yes.
what was up and above and below it, right?
Yeah.
But could you set it to what it was set to previously? Or like I don't know how to explain this, but like let's say you the head is like right, you
set the up and down of the current head to what the previous head was. So, so what it said is pre-have row down equal to pre-have row down left, something like that. Yeah. So, so the reason I was preventing to do that is because you have rotated your row, right? So currently the vertical pointers, like up and down pointers, is like messed up. So if you're calling like up down, I would say it's not reliable currently because, but if you can imagine how it's messed up, it's like still reliable. You can still like manipulate some way to make it pointing to what's your like desired position. But currently, I would just say if you're not sure, because if you do some rotates, right, it might just look like what in here. It just mess up. So you probably want to do some pointer like counting, like move to left twice or 3 times, so that will pointing to what it's currently pointing. So what I did is, so when I'm assigning up and downs, I won't use up and downs, so it won't be like messed up or it's pointing to the wrong position. So when I'm doing up and downs, I'm just pointing it to some other pointers. I was preventing using like up and downs there, because eventually we will like rotate. You will assign every element, and it's a cycle, right? So because you have already reassigned maybe the first element, and when you are doing the cycle back to the last element, you might use the pointers in the first element that maybe is already reassigned, so you might have a wrong pointer value. That's what I like encountered several times in my office hours. Like some of you maybe write a while loop to do this, but you use up and downs inside the while loop. So when it's at the end of the while loop, it's like the last element, you're using the pointers of the first element that is already been changed in previous loops, and you're assuming it's not changed. So that's causing like an error. So I would say I would recommend not doing that, because that might be like a little hard to think. So an easier way to prevent that is when you're modifying up and down pointers in a while loop, just not use it in the while loop, because it might cause some unpredicted issues. Okay. More questions? Okay. Then I think this is recording, yes. And it's copy.
Okay. And you just like went this way. Cool. All right, so I'm just gonna give you guys like a general overview of how copy works. Pretty simple. The only thing was there was this weird like vector thing that you guys had to do. So I'm just gonna draw that structure. Like the idea is basically you have your grid. I'm not gonna draw the pointers because it's gonna take too long. But essentially you want to somehow populate this vector of vectors. I think it's node pointers, could be wrong. I think that's what they called it, which is basically a matrix. So you can think of it like a, actually let's not do a matrix. Think of it as like another grid, right? So basically the thing is you're trying to store whatever data is contained in your original, the parameter that's passed in, and store it inside this vector of vectors. Okay, so that's kind of your goal in copy, and then You just have to do some minor modifications of pointers after. But basically the way that copy worked, as you guys worked on it, you probably figured out, was in order to store in this vector of vectors, we would have another vector of node pointers called something else. I'll just call it V. But basically what that vector was I think it went through the row. So it would kind of grab and iterate through all these nodes, take the data within, and then would stuff it inside this new node that you created, put that in this vector, and then once you're done iterating through that row, then you stuff that whole vector inside this A. Did that make sense? Any questions about that? I see some puzzled faces. I'm just going to do that one more time. So for example, say we go through this node. We're going to call, I don't know, say node pointer node equals new node. Let's just say we had a pointer P to it. P block. Sorry, this is getting quite messy. Does that make sense for everyone? Yes? I know some of you in office hours, this was a little new, but because Node has a constructor that takes in a block, if you have a pointer P that's pointing to a node, you're able to get the block that node contains, and you can now create a new node called node that's essentially the same object as whatever P is pointing to. Yeah? Does that make sense for everyone? Cool. Okay, so now since you have this new node, we're going to push this object into this vector that we made, V, and then continue down the list. So P is now going to move and point to the next node. Does that step make sense too? Any questions so far? Okay, cool. So after this, you're going to keep creating new nodes, and then you're going to keep going until you hit the end of the row. Then this vector is going to be fully populated, so it's going to have all the nodes in that row. And then now after that, you're going to call something like a dot. My writing is so bad. A dot pushback V. Does this line of code make sense to everyone? Because it's a little confusing. But because the elements in A is of type vector node, we can call this because V is of type vector node. Any questions so far? So this was the most complicated part about copy, I think, because there's a lot of things you guys could get wrong with it, but let's just quickly run through the code, because if you understand the picture I was drawing, this code will make a lot more sense. So basically what's happening is we're calling clear, so you also have to have written clear, and then you store number rows, number columns, pretty simple. And here is where we declare our vector of vector A. So that's that matrix thing I drew. And then here's where the magic happens, basically. So we're going to go through each row. Let me just go back to the picture. So for each row, this is 1 row, 2 row, 3 rows. Now we're going to make this new vector called temp. Okay, and temp is this thing. So far, so good? Yeah. And then you're going to have a pointer called PO to the head of row, or other dot head of row. Let's call it right there. Because J is 0, right? And then basically now you're going to iterate over the columns. So you have your pointer let me just erase this bit. So you have your pointer PO here, and this PO is going to iterate over all the nodes in that row. Yep. So every time it points to a new node, it's going to create this new node, which was basically this line of code that I wrote. And it has the block inside whatever node PO is pointing to. And then you're going to push back this new node you created, P, into temp, which is that vector. So it's this thing. Let me scroll down. Actually, sorry. Let's just keep it there, actually. Okay. And then you're going to set PO to be PO right. And because PO is declared outside the for loop, then you can keep reusing PO. Yeah. And then once this for loop is done, once it goes through all the columns, where is it? Temp. Temp has all the nodes in that row. And now we're just going to push back temp into A. So now we essentially stuff in a vector into this matrix. Does that make sense for everyone? Yeah, and that's basically the code part of populating that vector of vectors A. And then now, because these are just nodes, the pointers aren't pointing to the right places, or they're not really pointing to anywhere. You can basically steal this code from, I think it was in the constructor, right? This code was from, it was given to you. But essentially what this does, it just iterates through all the elements inside A, and then it'll just get all the pointers right. Does that make sense? So let me just draw a really quick picture. What's happening? Actually, there's no. Let's think about it this way. So you have your matrix A, and pretend the nodes are all there. Okay, the nodes are all there. What that portion of code was doing, what this thing's doing. Okay, I can't highlight the whole thing. But what that part of code is doing is it first looks at this node, then uses the indexes of A. So you see A, J, I, and it's all the indexes. It's using the indexes of A to locate which node should be on the bottom, on the right, top, bottom. And then it kind of just keeps on going. And it sets those pointers accordingly. Does that make sense? Any questions on that part? Cool. And why do we need this? Was this in the code? Was this the solutions? Why do we need that?
Oh, because you have to push back the head of rows, right?
I swear that wasn't in mine.
Because like for the row column, head of row column, head of column,
Yeah.
like vector, they're not being, you have to push it back. For the others, you have to copy the vectors to here.
Oh shoot, yeah, okay. Sorry. Yeah, so you just need to have the head of row and head of column also be the same. Cool? Cool. If there's no questions of copy, I'm just going to quickly go through clear. It's a lot more simple than copy. I won't draw a picture, but basically you're iterating through everything and deleting every node that you go by. I think this is pretty clear. You get the n rows and n columns. Then for every row, you're going to have a pointer to the head of row, and then you're going to iterate through all the columns, and you're going to set this temporary pointer node Q to be equal to P right, and then you're going to delete P, and then you're going to set P to Q. And then you're going to clear the head of row and head of column afterward and set B width and B height to 0. So just a really quick picture of what's happening. So you have your grid. You start the pointer here. Let's just call this cur. Okay. You set another pointer called, what do they call it here? Q. Q is P right. Then you're going to delete cur. So this is going to clear up that. And then you're going to set P to Q. Oh, sorry. Then you're going to set cur to equal Q. So cur is not going to point out anywhere. Cur is going to point here. And then you're going to keep going. And then Q is going to be equal to cur is right. You're going to delete this guy and set cur here. Does that make sense? And then once you're done going through the row, it's going to move down to the next row and then to the next one until you're done. Yeah? It's pretty simple. Any questions on clear? Yeah. Yeah, good question. So for example, if we didn't make Q, this is kind of what would be the situation, right? So let's call this cur again. Say we just straight up call delete cur without making Q, right? So cur is deleted, or whatever cur was pointing to is deleted. Now we don't really have a way to get to this node. So the point in having Q, declaring Q to be cur's next, is that after we deallocated that memory, we can still have a pointer to the node that we want to delete next. Does that make sense? Yeah.
What if instead of doing that, I don't think this code works, but what if we first set cur to cur right, and then we delete cur? That would work.
Oh, yeah, okay, yeah.
Like, I think I did it in a way, so I think it will work.
But then what if, I don't think it worked. I think there'd be a segmentation fault, right? Because you would keep deleting, and then you get to the last one, then you would go.
Yeah, you would have like a condition.
You have a condition, right? Yeah. Okay. If you have a condition, it would work. So yeah, you could do either implementation. Both are okay.
So what I did is I put the head, like what the head is pointing to is the last element that was not deleted. So I delete every other thing, and then the last step is iterate through the head of row, the head of row, and delete every, like the first element of the row, and everything is done.
Any other questions? Yeah.
One question for like initializing the vector.
Initializing the vector. Okay, yeah.
And then I was looking up online like how to do it.
Yeah.
But I saw this pushback method, but I also saw that there was a way like initializing one line, the height and the width. Like
Okay.
Reassign it. What would be the difference?
What would be the difference?
Like, yeah. Is this like in stack memory if I do like this? Reassign the width and the height.
I think it would still be stacked, right?
It'll be the same thing,
Yeah.
because here we are not initializing the sign, so it's initialized is like 0 by 0, right? But if we are initializing the size, it will have like maybe n by m like nulls, right? Or it's nothing, just there. And you can access it by using the indexes. So that would be easier if you're doing maybe other stuff, like you're not pushing back, you want to maybe put some element to a specific index. So you might want to initialize it to a bigger size so that when you're accessing that index, it has been like initialized. So you actually have that index. But here, if it's 0 by 0, you want to access maybe 3, like 3, 3, right? It's not initialized, so it will give you an error. So if you want to just get rid of that error, you can just initialize to a very big vector.
So it would still be possible to do the pushback even if you initialize it?
Oh yeah,
Yes.
Okay, I see.
yeah. Just maybe more prone to error, but
But
it
I
would
don't
work.
know if the pushback will push to the end of that initialized stuff. So if you initialize it to maybe 10, like a vector of length of 10, I think pushback will push it
To
the
11.
11th element. So that's good.
Yeah, that's true.
But then you would have to check, like once 10 is filled, then you push back.
I think in your case, if you initialized the height and width to be like the height and width of other, then you'd kind of do more like of an array assignment kind of thing. You would go like A and then have the indexes and then equals whatever. Yeah, but it could work. Yeah, doesn't have to be this way. Any other questions or comments on any of the functions we talked about? Talk about if you thought of any questions about rotate, you can also ask that. Or are you guys good? Yeah, that's it.
Just go back to
Clear, yeah, sure. Where is clear? When are the solutions? Are these going to be posted? I don't know.
I think it's already posted.
No.
Solution.
We can talk to Cinda and Will on Friday because I don't see why they shouldn't be posted. Because you guys literally are just looking at it right now.
We don't, like, for the previous time, we never released PSH. I don't know.
Really?
So we did.
You guys could just take pictures the whole
Yeah,
time.
we just need pictures.
Yeah, we can talk to them. I mean, I feel like it'd just be easier. But maybe there's some rule I don't know about. Is there a rule?
Every semester PSH.
It's true.
Is that right?
Okay. Yeah. Cool. Guess we can just